right, welcome back. We're going to go through some additional problems on how to use the power rule and its applications. Well, first off, here's a problem. How would you solve someone like this? Well, looking at this one seems very, very complex. Uh, Many students probably look at it and have no clue what to do or not really sure where to start. Well, what I would probably do first is do a little algebra. I would simplify this. Whenever you're given a complex problem, the first thing you want to do is use algebra. Algebra is your friend, if it's done correctly, or it can be your worst enemy, is your friend. So, what does that mean? Well, in here, what we see is a expression that can be factored. So, in order to do this, okay, since we don't know any other real rules yet, what we're going to do is we're going to factor this, okay, distribute. So what we have is we're going to factor the x squared, or x through, so we have x cubed, plus we have the x squared, and then we have plus the x. So I'm distributing the x to each one of these values. All right, one there, and then one there, and then one there. Then we have to take the negative 1 and we're going to distribute that through. So we have negative x squared. All right, we're going to take that, and we have negative x. And we take the last one, we have negative 1. From here, what we're going to do is we're going to now simplify. Okay, when we simplify this, and obviously all this is going to be over x cubed. Okay, so that's all over x cubed. From here, what we're going to do is now we're going to simplify. Well, we notice that if I'm going to change my color, I bring up my handy dandy cancellation red marker. What we have is we can cancel this out with that. We know this can cancel out with this. And now what we have is right here a new expression of x cubed minus 1 over x cubed. Now from here, what we're going to do is, well, we cannot use the power rule with this. If you've learned the quotient rule, we can use the quotient rule, but I wouldn't even use the quotient rule. We're going to go keep on doing algebra because he's our friend. If he can't do it, no one can. It's a little joke. But what we're going to do is we're going to do a little algebra. I'm going to take this x cubed, and I'm going to divide it into each one of these expressions. So if I take x cubed divided by x cubed, well, what I get is, all right, x cubed over x cubed. Well, that's going to equal 1. That's x cubed. And then we have minus 1 over x cubed. I apologize for my penmanship. And what we have, this is going to turn into 1 minus 1 over x cubed. Well, I can change this into x to the negative third power. And so what we have now is y equals 1 over x to the negative third power. Well, from here, now, once we got all that stuff, this page a little bit, we can now use this expression and now find our derivative. I'll change this to blue. So we're going to have y prime now, our derivative, is going to equal the derivative of 1, which is 0. And now we're going to take the derivative of negative x to the negative third. We'll use the power rule. We're going to take negative 3, put it in front. So I'm just going to write this out. All right, the negative 3 in front, x, take negative 3, minus 1 using the power rule. And what we have then is going to be 3x to the negative fourth. And that equals y prime. All right, you can simplify that if you wish. 3 over x to the fourth. Pretty sweet, huh? Yeah. All right, so that's how we took a very complex problem. All right, using a little algebra, distributing this through. All right, make sure you do that correctly. All right, once you have that, it's simplified very nicely. Simplify more, make a power function, a simple power function that we can solve, and we can get our answer. Very nice, huh? Well, that's just one example of how we can use algebra to simplify and create this and solve a problem like that. So I'm going to do another one here, right there. And in this one, and this is a problem number 27. It's a book problem. Yeah, but right there. What we have is that we're going to find the equation of a line perpendicular to a tangent to the curve at y equals x cubed minus 3x plus 1 at the point 2, 3. All right, so we want to find the equation of a line that is perpendicular to a tangent. Okay, tangent. Well, as soon as we see tangent in the equation of a line, the first thing is what we need to do is whenever I figure equation of a line, we need to figure out what the point, we need to find a point and a slope. That's what I always say to my students. whenever I need to find the equation of a line, I need a point and a slope. Well, I'm given our point of 2, 3. 2, 3. Our slope, well, that is perpendicular to a tangent. Now, tangent slopes are derivatives. So we can find y prime at that point. We want to find a line that's perpendicular to that. And if you remember perpendicular is opposite reciprocal. All right, the opposite reciprocal. All right, reciprocal. So the first thing we're going to do is, I'm sorry, I'm writing on an angle, but what we're going to do is we're going to take y prime and we're going to take the derivative of this. So that's going to be 3x squared minus 3. Now to find our slope, all right, we're going to now take and plug in 2, all right, our x value. So we're taking 2 and we have 3, all right, 3, and we have 2 squared, which is going to be 4, then we're going to have minus 3. So we're going to have 12 minus 3, which is 9. Okay, 12 minus 3 is 9. Now that is our slope of our tangent. However, we're looking for a line that is perpendicular to our tangent. So we know that our perpendicular slope is going to be the opposite reciprocal of that. So there's our slope. That's the slope we want to use. So from here, we can now find our equation of our perpendicular line that's perpendicular to the tangent. We're going to have y equals our slope. I'm going to put this into point slope form. X minus 2, and then plus 3. And that is the equation of my perpendicular line to the tangent on the curve on my cubic function at 2, 3. We also call this a normal line, if you're wondering about that. Maybe you've talked about that in your calculus class. But normal lines are perpendicular to tangents, just for future reference if you're looking for that terminology. All right, so we went through and did 2 applications, all right, of how we use derivatives. One was we used algebra as our friend. The other one, we found out the equation of a line by knowing we need a point in the slope. All good using the power rule, one of the fast, efficient ways of finding derivatives. So I hope this helped you out in solving some problems. And then good luck and God bless the rest of them.